Welcome to our Going Green podcast. We're coming up to November the 5th, bonfire night. Remember the 5th of November, gunpowder, treason and plot. For I see no reason why gunpowder treason should ever be forgot. And we set off a big bonfire, and they seem to have gone over the years, and we launched these fireworks into the air, causing massive air pollution, Paul.
Yeah, well, unfortunately, it's one of those things where it's the only day of the year, or more precisely, other festivals, but we're specifically talking about bonfire night, is where we decide to celebrate a festival by burning pretty much anything and everything. This ranges from fireworks, but it could also be bonfires. I mean, there are where you burn your stacks of wood and effigies and things. And
typically, Guy Fawkes, to remember him trying to blow up the House of Parliament. Exactly. There are some people that believe that
should be done again.
Anyway. Yeah, okay, but we'll move on rapidly from that, yes.
Yes, anyway, so the idea of these festivals is, is to burn things in celebration because it's cold winter months, right? And fireworks and bonfires create warmth and gather communities, and that's great. Except, the fireworks, we'll take fireworks specifically. They create pretty lights and flashes and powders. But the reason they create those flashes of light in different colours is because, of course, they're made from different metal salts. So they basically wrap the metal salts around a gunpowder charge to create the...
Okay, so let's start then. What is a firework? I think that's probably a good place to start. What is a firework? So I would have said a firework consists of, let's think of the rocket as an ideal firework. So this contains gunpowder, typically a black powder, which is made of some really good chemicals such as sulfur, and that's going to burn to make sulfur dioxide. We've got some charcoal. That's going to burn to make carbon monoxide and carbon dioxide. And we've got some potassium nitrate, which is going to sort of provide some of that oxygen and get it going. And that's going to make potassium oxide, potassium hydroxide probably. We're going to get some nitric acid out of that. And all that is just to get that little rocket up into the air. And then when it does that, we've got another explosion of gunpowder that's going to then spread out all these different colorants. And these colorants, as you said, are the different sort of metals. And I'm going to give you a little test now, Paul.
Uh-oh.
Well, you're the one with the chemistry degree. So we've got the color red, which are...
it's going to be strontium, I think.
And lithium. Because if you want that deep, intense crimson, then that's lithium. Okay, orange.
That's going to be sodium, isn't it?
No. Oh dear, that's going to be calcium.
Oh.
That's the one I can't see. I'm colourblind, and everyone says, look at that wonderful sort of colour of calcium. I go... Yeah. Right. Yellow. You've got to get this one right.
Well, yellow is the sodium because it's the sodium lights from the street lights that we used to have.
Okay. Let's go for green. What do you fancy for green?
I'm going to go for, I think, isn't it copper?
It can be copper, but largely barium.
Oh.
Which is one of my favourites, one of my favourite experiments we do when we make dragon flame. And we put a tiny hint of barium in there, and it comes out green flames. Sorry, me. Blue.
Oh, it could be. I don't know then, because I thought
that's going to be copper.
Oh, is that going to be copper?
That's going to be copper. So we get the bluey. It is a bluey green, but it's a blue of copper. Right. And then how about purple?
Well, I know purple cheats. Because it's not purple at all. It's a red. It's a mixture of red and blue together.
That's right. So that's copper and strontium.
Yeah.
So we've got all of those in there, and then we've also got the other ones, which are that bright white, and that is typically
Well, it's typically a magnesium. That
magnesium. Well done. So
burns.
I think, me teaching chemistry and you got the chemistry degree, I think I did slightly better on some of those. Yeah, so we've got then those sort of explosions, those little stars, typically in whatever shape they might want to try and make them. And they're going to be things like, well, can be calcium metal, and also if they're sort of a yellower color, reddy orange, or typically they're magnesium, and tiny little pieces of magnesium flying through the air. All right, so that's what firework is. So let's now ask the simple question: do fireworks cause bad air quality?
And unfortunately, the answer is yes.
Well, that's the end of the podcast, isn't it?
Over and done with, no problem.
Right, okay, yeah.
Now, but it's not as interesting as you think. You see, around any festival where there are fireworks, there is a sudden increase or peak in what is known as particulate matter. As in, so you've got your firework, which generally combust into lots of gases.
Yep.
Right. And, these are carbon dioxide, monoxide, and probably a nitrous oxide, all sorts of.
My favourite, sulfur dioxide, sulfur trioxide.
Yeah, all the lovely gases. So we're not saying no, but anything that hasn't burnt up, and that's typically the metal ions or the metal salts, they actually don't burn up fully. They don't burn, to vapor, essentially. And so basically they're little particles, balls of metal, that's about the size of a diameter of a human hair. Okay, that's fair enough. That's no problem. And that rains over the area of which a firework display happened. If it is across a city, it's across, they just fall down gently. And over a period of 2 weeks after the event,
they are still raining down.
They are still raining down on people, right? And depending on the wind flow and wind direction, there's obviously all those things, but we come down. And
so those particles come in different sizes, don't they? There's typically what we call the PM10s, which are up to 10 microns in diameter. That's the same size as sort of mold and pollen. And then, they're floating in the air. You're going to breathe them in, and you're breathing in things like some lithium, some strontium, some calcium. I'm not sounding very good here, is it? I don't like the sound of that. Then there are also the really fine particles called the PM 2.5s, which are in the region of about 0.3 to 2.5 microns in diameter. And that's sort of the size of some of the particulates we get from, cars and factories.
Yeah, exactly. So you've got these range of sizes relate down to pollen, and they go in the air and they float around in the air, and we absorb them. I say we absorb them, we breathe them in like we do other pollen and those sorts of things. And the problem is, let's say copper. Let's just take a very good one.
Excellent copper, isn't it? I love copper, sort of a good gnawing of a bar of copper will. Oh, I've just read the label on the copper.
Yeah, the copper kills.
Yeah.
And it's also on so CLEAPS is one of the ways where it's a regulatory of what is, how polluting it or how damaging it is. And unfortunately, copper's got a lovely sticker that says harmful to the environment.
Kills sort of a lot of things.
A lot of things. And it's because it's water soluble. So half of these salts that are flown down are water soluble, which means they can go in the water table. And that means
you drink them then.
You drink them, exactly. So that means not only do you breathe them, but you also can drink them. That doesn't seem too great.
Now, I'm going to make it life worse for you because I got down 2 particles, but there's another one. There's another 2, actually, I'm going to give you. And there's what we call the ultra fine particles. These are particles below 0.3 microns in diameter. Now, these ultrafine particles, UFPs they're sometimes called, and they make up how much of the natural sort of air particles we get? Any ideas?
Oh, 50?
That was a good guess. Way off, 90%.
Good God.
90% of all the particles are less than 0.3 microns in diameter, and these basically stay up in the air for yonks.
Yeah,
The yonks is an interesting number.
well, especially if you're talking about New York, because New York yonks could be even.
It is.
Anyway, but they can basically. So this is where they've
Years.
studied up. Yeah, they've been doing lots of studies. So I'm reading in 2007 study to a 2014 study. They're saying they result in these particulate matters. They stay up in the atmosphere and can rain down for over 5 years after an event. So, but the critical problem is the event happens every year.
And not just every year, but we have particles happening, these fireworks happening. Well, we have, in America, they like the 4th of July. They don't celebrate Bonfire Night. They have 4th of July, but usually...
You've got Diwali, which is...
yeah, New Year.
New Year's all over the world. And
competitions to see who can make the most pollution.
Yes, so... And anyway... So in relation to suddenly all this pollution happening, we can see that there are events that cause high hospital emissions. And you say, well, what do you mean high hospital? And these are hospital emissions of people with asthma, or at least of it. Yeah, it's one of those things where, chest pains and chest symptoms. Yes, not necessarily just asthma, but in relation to absorbing all these metals and compounds, they don't do you good for your body anyway when you've just ingested. So one they call is a chronic obstructive pulmonary disorder. Whoa, doesn't seem so good, but that's basically something's in your chest and basically obstructing your airways, which is, as you know, is bad. But you look at, all right, asthma.
Yep.
Okay. What is the other problems associated with people who have asthma?
Well, you mean apart from not being able to breathe and dying?
Oh, not problem being able to breathe and die. No, but it's very related, right? People from asthma suffer headaches.
Yep.
Because they suffer a swollen throat. Funny that, because it's a problem with the asthma. Laryngitis, they have lots of problems with laryngitis. All these complications caused by...
And this isn't going to happen on the night of the bonfire, the firework night. It's going to happen for weeks afterwards.
Weeks after, up to the sighting I've got here is that a month after the event, they have a spike, or hospitals have a spike of asthma related, because it's the whole or respiratory infections issues over the month after a firework event.
And I would imagine with the coronavirus affecting respiratory systems, we're going to see a lot more people.
Yes, unfortunately, yes. But there is one of those things where with the fact that we're having the coronavirus around, which most people won't think of, is the fact that we're wearing N95 masks, which actually would make sure that 95% of the material won't get breathed in.
And what size particle would get through there, Paul? Do you know?
Unfortunately, the ultrafine particles.
Yeah, and that's 90% of the stuff.
I know
is going to go in. There's another one in there that also is not really mentioned so far, and these are the volatile organic compounds. Now, when you get the sort of reaction going of the gunpowder, we sometimes form special volatile organic compounds, and when the fireworks are made, they make quite a lot of these chemicals, and a lot of these things aren't particularly nice. Quite a few of them have got chlorine in them, and these are, in fact, also greenhouse gases, let alone the sort of nasty things they actually do to your body, because quite a lot of them are actually quite toxic.
Who
And
would have guessed?
and how about N95 mask? Will that stop any of these volatile organic compounds?
Well, a little bit. It depends on
Yeah.
their size. You could talk about where, but a lot of these actually, I was reading, don't actually come necessarily from the firework itself. A lot, if you're, say, doing a bonfire, that's actually where lots of them are coming from more.
Yeah,
But
it's a good news that a lot of bonfires aren't done nowadays. Nothing like as many of those are done as they used to be. When I was a child, everywhere had a big bonfire, whereas now the bonfire isn't so sort of common. Instead, it's just the firework festival that they
yeah,
have.
yeah. So it's not as, I wouldn't say too bad, but it's not as problematic as one might originally seem. So there you go. So basically, the firework events are bad, generally bad for health or bad for respiratory problems, and so that leads to the critical point is sort of how do you protect yourself from these things? Now we talked about masks.
That'll work.
That'll work, but we talked about the problem with the masks is the problem, right?
90% of the particles are still going to get through.
Yeah, yeah. So now another thing we did see, and this is very recently in a study of 2019 and 20, is that because COVID-19 happened, we weren't allowed to mix. So lots of people had homemade, or not homemade, fuzzer, household firework nights using lower grade or lower quality fireworks, which of course have, I wouldn't say worse ingredients, but the ingredients generally are more polluting. They have more pollutants when combusted. And so instead of having a large firework festival where a large crowd gathers and sort of it's not as bad for individuals, say, because it's a bit more spread out and a bit more, there's more air in the mix, so you're less likely get them.
Often they're higher up, aren't they?
Yes.
Yeah. So if you have your own little fireworks, you often have sort of low down fireworks, and it'll be sort of, and you see the level of smoke in the garden. And of course, you're breathing in that smoke, which are all those particulates, all those metals and poisonous gases.
Yes.
Yep.
Right. So that's fair enough, and so there's no problem with that. So one of the things they were talking about in those loads of articles we did from research for the podcast is that unfortunately because of these lower grade fireworks, while more polluting, is actually better to go to a more, I wouldn't say public fireworks display. That's the wrong way to put it, but is to go to a public one where there is a bit more higher quality or high ingredient fireworks that basically produce not less toxic, but are more cleaner in their pollutants, as in it's going to be pure copper as opposed to copper plus something else, if that makes sense. So it's very clean in regards to how they're polluting, which is a bit novel in the concept of pollutants, but a clean pollutant is better than a dirty pollutant.
Yeah. Okay. So we've got those. So your own little fireworks sound like a good idea, but in fact aren't such a good idea. So one way you can protect yourself from fireworks and the air pollution and all that is you could go to a big display.
Mm-hmm. Yeah.
All right. If you don't want to go and watch the fireworks, but you're still going to have to breathe it in, what can you do?
Well, this is the problem where, yes, a mask would improve, but as you said, not all of it doesn't go through and pass through, because then it's sort of like, the answer is to be more further away.
Yeah. And if you have to be close, then shut your doors, shut your windows.
Yeah. I mean,
And that's going to keep a lot of the toxic chemicals out, and don't open them, I would suggest, till at least the next morning and probably the day after that, really.
Yes. So it's hard to say really in that regards to
How about an air purifier
As in for
in your home?
in your home?
So yes, you can actually use air purifiers, and some of them will capture quite a lot of the larger particulates, not the smaller ones, and that can sort of keep your air a little bit safer.
Yeah, I suppose it's got a filter that can vent out all the nastiness. So that's fair enough. There's no
But
problem.
it'll take out the particulates down to about 2.5 microns.
Yeah, which is the same as a 95 mask.
Yes.
So yeah, it sort of gets there, but it doesn't quite get there. But nothing can. That's the problem.
That is the answer, that nothing can.
Nothing can, because it's so, the particulates are so small, and So another thing I was quickly reading up about is the fact that you can actually buy eco-friendly fireworks.
Oh, that sounds good.
Yeah, and it's sort of like, what's the specialness about eco-friendly fireworks?
So I'll ask you a question first of all. Can fireworks ever be eco-friendly, really?
And the honest answer is technically not.
Okay, so they can be friendlier.
Yes.
Okay, so
And this is doing simple things like taking the ingredients and swapping them around, or taking them out. Like if you reduce the sulfur content of your firework, therefore less sulfur dioxide is produced, which makes a lot of sense. That's fair enough. That works. You remove the sulfur, less sulfur is used up.
yeah, that sounds quite useful.
And of course, that means then you're creating less small particulate matter, and you actually make larger particulate matter. This is one of the things I was reading about there. Instead of doing the small, making a firework so when it does burn, it burns big, as opposed to the small, fine.
And the bigger particles fall out of the air faster.
They can be stopped by the mask and the air filters. So,
of course, they are going to go straight into the ground, and that causes some problems.
Well, that does cause problems. So it's not, fireworks aren't green is the point. Yeah. But if you can reduce the pollution or pollutants by 15 to 60% in that firework, then you're not dealing with 100% of the pollution. You're only dealing with 40% of the pollution, which is a much more, I wouldn't say bearable amount. That's the wrong way to call it. But you can deal with a little bit of pollution as opposed to a lot of pollution.
So that's on the propellant side, but on the actual color side, there's not much we can do, because it's still those metals that are used to produce all those wonderful sort of pretty colors that we like.
Yeah, and the answer is, do you use, instead of using harmful metals, or instead of going, I want all the colors of the rainbow, you stick with a few lesser dangerous chemicals or colors, the calciums and the magnesiums, right?
Which are available in most water that we drink.
Exactly. So the metal ions or metal salts aren't going to the ground source, aren't actually pollution or pollutants, because they're already there. So, yes, you're increasing the concentration of them, but is that going to matter when they don't do anything? So there's those sorts of ideas where just by simple thought of what you want to do for a firework, you can actually reduce the environmental impact, or make them greener just by a little bit of thought. So it's a simple matter of that regards of.
Yeah, because I cheat when I go to the firework display. I usually put the television on. I watch it typically on nights like sort of New Year's Eve, and I can watch them around the world, and I don't have any problems breathing in the gas that's sort of made in Australia or whatever. But how else can we get around this? How can we make these firework displays more eco-friendly? And the answer could be, let's just not use fireworks.
which is a sort of in conversing. So you're going to a fireworks festival, and yet you're not going to use any fireworks. Now, this was seen in the Tokyo Olympics this year, where instead of a major fireworks display, yes, they had fireworks, so we will glance over that, but they were using a swarm of drones to create a pretty, I say, pattern, create visual effects. Because you've got to look at what is fireworks, and the answer is fireworks is basically a light show in the sky.
Yep.
So what if we just remove the fireworks and just put a light show in the sky?
So we can do that with lasers. You can have laser beams sort of dancing around, and you can have drones flying in formations with all pretty LEDs, and that's going to look quite nice. I've seen quite interesting ones of all sorts of shapes being made as the drones work together and they morph from one shape into another. And they don't look too bad, because you can sort of guess what the next shape's going to be. Can you recognize what this is or that is?
Yeah, it's almost like a marching band in relation to the patterns and they form and do.
Done to music.
So, it's all the festival stuff the fireworks give, but without the pollution. The last thing I was reading about different shows is because what in relation to the fact that it's a light show is lots of cities now have outside lights, or more precisely, lights on the buildings. And so instead of doing a festival light in the sky, you do a festival
light on the building.
Light on the building. And you can actually do, if you stand on a hill overlooking the city, then the city then becomes the performance.
I've seen Tetris done on buildings. I've also seen on the London fireworks where they actually had all the numbers on a countdown on the buildings. 5, 4, 3, 2, 1 sort of thing.
Yeah, exactly.
So there are alternatives to all these sort of firework displays, I suppose.
Yes, and they're not.
It won't be a firework display, of course. It's going to have to be then some sort of light in the sky display, but without the asthma, without the laryngitis, without the CO2, the sulfur, the nitrous oxides, and all the pollutants.
Exactly.
And if we're getting to this stage, and we're going through COP26 this week, we're looking at sort of how we can do things. Basically, a fireworks night adds a terrific amount to the pollution, and it stays up, as we've said, for right up to about 5 years. So how do we get rid of it? Well, perhaps we need to change our attitude on not necessarily having a fireworks display. We can remember the 5th of November, but we can remember it with some drones in the sky, with pretty sort of buildings doing sort of different patterns and playing different things. We can have lasers, all of which will probably make life perhaps a little bit safer.
Yeah, and make the air much more cleaner.
Yeah. Right, so thank you for listening to our Going Green podcast. Next week, we're going to do something about the results of COP26, and we'll see what it actually has managed to achieve. So until then, it's goodbye from me.
And a goodbye from me.
Goodbye.
Bye.